Ladies and gentlemen, boys and girls, men and women of all ages, welcome to Geometry Midterm Review 1. Let's get ready to learn! Dun 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 da 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 dun 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 da 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 dun dun da 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 da. Hey, Mr. Zacek back and better than ever here, getting ready for our midterm exam. So I'm going to do some review today, and this is going to be a video key for the what we've got going on. So I'm going to answer the questions, share some things, kind of tips to recognize with it. So in number 1, it says find the value of x. Well, what do we see here? We have intersecting lines, and we want to recognize that when we have intersecting lines, we have one of two relationships. We either have congruent vertical angles, or we also have linear pairs, which are supplementary. And so in this case, what we have is a linear pair. So we've got 4x plus 10 plus 3x minus 5 equals 180. So this would be 7x plus 5 equals 180. So 7x equals 175. So when we divide by 7, 175 divided by 7 is, I'm going to do that. My math, doing that in my head is not working right now. So 175 divided by 7 is 25. Seems like that should have been easier. All right, so there we go. Good to recognize. Question 2, given k is -6, -2, and m is 2, 2, the midpoint of kg. Okay, find the coordinates of g. So kind of the key thing to recognize in this is, am I looking for a midpoint, or am I looking for an endpoint? Right? That's the question. Which one are we looking for? Well, we're given k and m, the midpoint, so that means m is the midpoint of kg, so we're looking for an endpoint. So the way that we've done that predominantly this year is, instead of using the midpoint formula, we've said, okay, k is -6, -2. The midpoint is 2, 2, so let's figure out the change. So to go from -6 to 2, we're going to add 8. So to get over here to g, we're going to add another 8, which would be 10. And to go from -2 to 2, that's adding 4. So we're going to add another 4, which would be 6. So 10, 6 would be the coordinates of point G. So again, some people go and they just start doing the midpoint formula right away, but when you get one of these questions, make sure you ask, am I looking for the midpoint or the endpoint? Okay, find the intersection of planes ABC and LMO. All right, now this is going to be a little hard to illustrate with on here, but if we have two lines that intersect, we're looking for a point. And if you take two pencils and cross them, you'll see that's a point. But if we have two planes that intersect, we're looking for one line. So you could kind of take your hands and put them together, you know, make them like your hand a plane and a plane, and look at that and see a line in your hands. Or the example we've talked about this year is the ceiling and the wall. Where do they meet to form a line? But you want to think two planes, this is going to be a line, okay? So that should be this line right here, AC, and because we know it's a line, we're going to put the arrows on the top. All right, in one of our earlier quizzes this year, one of the common mistakes that people made was they wrote segment AC instead of line AC, and we took a point off for that, because even though it looks like a segment in our picture, because we're told it's a plane, we know that planes extend forever and ever, and so we need it to be a line. All right, are the lines parallel? When I see parallel, I think same slope. Are the lines perpendicular? I think negative reciprocal slope, or neither. Well, when you have a slope question, if you're given points, you're going to use the slope formula. When they're in an equation, we're going to put the slope-intercept form. That's how we're going to figure out what the slope is. So y equals mx plus b. I'm trying to figure out what is m. So if we take our first equation, 2y equals 4x plus 10. If we divide everything by 2, we get y equals 2x plus 5. Sometimes people like to write it as 2 over 1. Okay, so then we have 6x plus 12y equals 8. I'm going to subtract 6x. I'm going to get 12y equals negative 6 plus 8. I'm going to divide everything by 12. Okay, so we're going to get y equals, I'm going to reduce that, negative 1x over 2 plus 2/3, I think that reduces to be. So now all we're interested in is the slopes though. So the slope for this one was 2 over 1. The slope for this one is negative 1 over 2. So the lines are perpendicular. Okay, because the slopes are negative reciprocals. Okay. Alrighty, so question 5. Given points A and B, find the coordinates of P on the directed line segment that partitions AB into the ratio of 1 to 3. All right, so we got a directed line segment. My fraction is going to be 1/4 that I multiply by. And so I've got x1, y1, x2, y2. Bunch of different ways people think about this. One of the ways that we've done it is to take A, which is negative 5, 4, and B, which is 7, negative 4. And we're trying to find the difference between the two. So, x2 minus x1. This is x1, y1, x2, y2. All right. Another way of thinking about this would be the run. So 7 minus negative 5 is 12. What I like to do is go back and look at, if I go from x1 to x2, do I add 12? Well, to go from negative 5 to 7, yes, we're going to add 12. Okay, y2 minus y1 is negative 4 minus 4, which would be negative 8. So is the change in y to go from 4 down to negative 4? Yeah, that's down 8. So we start with our x1, so we're going to do x1 plus 1/4 of the change, which is 12. So x1 was negative 5 plus 1/4 of 12 is 1/4 of 12 is 3. So negative 5 plus 3 is negative 2. So then we do the same thing with y1. y1 plus 1/4 of the change in y, which was negative 8. So y1 is 4 plus 1/4 of negative 8. So 1/4 of negative 8 is negative 2, which would be 2. So point P would be the point negative 2, 2. Okay. Now again, one of the things that we did mention was if you're doing this on a well, that one's not going to work. But you could graph this out and plot the points and make sure that that point actually falls on there. So let me just do kind of a real quick sketch. So negative 3, 4, 5, 1, 2, 3, 4. All right. And then 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. Negative 4. So this is kind of that's our directed segment. Does the point negative 2, 2 fall on that segment? Yeah, it does. Okay. And it's, in a ratio of 1x to 3x. This is 3 times the length. So kind of passes the eyeball test there with that. And again, if you have graph paper, you can do that more specifically. Okay, find the coordinates of midpoint of TR. So again, with our midpoint question, we want to think, am I looking for the midpoint or am I looking for the endpoint? Okay. Well, in this case, find the coordinates of the midpoint. So now we're going to do our midpoint formula, which is x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. The midpoint formula, that's for you. You have to add and divide by 2. So 8 plus negative 6 over 2. Negative 3 plus 8 over 2. So the midpoint, we should write this out, the midpoint of TR equals, so that would be 2 over 2, which is 1, and 5 halves, or 2.5. Okay. Number 7, find the length of AB. Now you want to think length is distance, all right? Now notice AB, when they write AB without the segment bar over the top, that's another way of indicating distance. So our point is x1, y1, x2, y2. So AB is going to equal x2 minus x1 quantity squared plus y2 minus y1 quantity squared. Take the square root to find the distance. Take the square root to find the distance. So x2 is how much the x value is changing. And y2 would be negative 8 minus 5. Okay, so we get 9 squared and negative 13 squared. So again, go back and look. All right, if I'm going from negative 2 to 7, yep, I'm going up 9. And if I go from 5 to negative 8, I'm going down 13. So if you're doing this, what you want to put in here, so this would be 81 plus 169, and so AB is going to be the square root of 250. Depending on what the question asks you for, whether it says find the length in simplest radical form or to the nearest tenth or something would tell you what to do. If it was simplest radical form, 250 would be 25 times 10. 25 is our perfect square, so we could say that's 5 times the square root of 10. All right, so again, depending on how that question is being asked, would guide that last step with it. All right, now we're going to get into some constructions. All right, construct an equilateral triangle and circle R below. So this construction was one that we didn't do in the notes. It was one that we did on a problem set, and when we did that problem set, I just had you come up and we did it together. Okay, the way that you do it is you measure out the radius of your circle. Okay, and then you come over and you pick a point anywhere, it doesn't really matter where, and you start on your circle, and what you're going to do is you're going to go up and you're going to move your compass around, and this is one that you can, it's one of those ones where it's sort of easy to do the right thing and it can look wrong because we have a lot of compass error that shows up in this. Okay, but we're going to keep on moving. So if we do it correctly, we should get 6 evenly spaced markings around the edge of our circle. Let's see how I did. If I got it close, or am I off a little bit? I'm off a little bit. That's okay. I'm not worried about it. And then I take this and I just connect every other one with a straight edge. Okay. So again, if you're looking at this, you might want to write a note to yourself and say, start by measuring the radius. Okay. All right, number 9, construct a 30, 60, 90 triangle. Okay, so this one's tricky. And the way to approach it is to start with the 60-degree angle and recognize that 60-degree angle happens in an equilateral triangle. So if I come over here and I measure AB with my compass, and I come up here, and then I do the same thing on the other side, that intersection point will create an equilateral triangle. Now, what do we know about an equilateral triangle? Well, in an equilateral triangle, we know that all of the angles are 60 degrees. Well, what do we know about, whoops, don't do that. If we take half of a 60-degree angle, we'll get a 30-degree angle. So what I'm going to do is I'm going to come up here and I'm going to do a bisector, an angle bisector of this top angle. So here, now I got to bring my compass point over here. All right, so there's an angle bisector construction. So and now I'm going to bring this down. So what do we got going on? Well, we got a 30-degree angle because we just divided 60. Well, if we have a 30 and a 60, the last one has to be a 90. And in this case, we actually made two 30, 60, 90s because both of them are congruent to each other. Okay, so that's probably the most straightforward. The key in this one is with side AB. So we've got a side length that has this side over here would be, this side right here would be the length of AB. Okay. All right, I think we got some more constructions now. Circumscribe. So circumscribe, when I think about circumscribe, I think about the circumcenter. And so I need to find the circumcenter. That's going to be the center of the circle. And the circumcenter is the intersection of the PB, perpendicular bisectors, PBCC. That's how I recall that one. So what we're going to do here is, see if I can actually, I don't know if I can make that a little thinner on my compass. I'm going to start and I'm going to pick two sides. I'm going to do the perpendicular bisector of those sides. Perpendicular bisector is our kind of surfboard construction. So above and below, and take a straight edge, and this line is thick, so it's a little tough to, might create some inaccuracy. The thickness of that line could create some inaccuracy. We'll see. And then I'll do the surfboard over here for this side, above and below. And over here, we're going to go above and below. And I'm going to connect those two. Again, I've got a pretty, this little tool has a pretty thick line, so that could create some inaccuracy. Now, the nice one about a circumcenter is once you get those two, you've got the circumcenter, and now it's a matter of adjusting our compass to come out to touch one of those outside points, and at that point, we're creating a circle that goes around the outside that circumscribes that triangle. Okay, so now we want to inscribe, and the way that I remember this is AB is in, meaning the angle bisectors are where this, what's created for this. So I'm going to start over at this angle here. And we're going to, let me see if I can again make that real thin. So I'm going to come up here, do our angle bisector construction, kind of assuming that we're familiar with this one at this point in the year, so we're going through that. Good. All right, and now we're going to, we got to do two of them, so I'll come over in this angle. Doesn't really matter which one you do, but I'll go ahead and do this angle here. So I'll go up here, and we got this one. Don't get confused with the last intersection that you had. Okay, so that's going to come out of the vertex, and we've got ourselves the angle bisector there, meaning this point is the in-center. Now what's different about the in-center than the circumcenter and from the construction standpoint is now I've got to go, and from that point of intersection I've got to create a perpendicular line. So what I'll do is just use a different color for this part of it, but we're going to swing an arc that hits down here at those two spots, and then we're going to come here and we're going to come over here. So this is a perpendicular from that point down to the side of the triangle. So we're going to go from there down through there. Whoops, I feel like that's off a little bit. Let me see if I can adjust that. Okay. Yeah, again, you know, thickness of the line giving us a little bit of trouble with that. Okay, so then at that point we want to use that line that we created right there to give us the distance of the radius of this circle. So it's going to be, oh, I need to go down just a little bit more, and then there we go. And so I'm off a little bit. That's to be expected with, you know, all those things changing. All right, so a couple key things to remember about a circumcenter is that this is equidistant from the vertices. Think the question, the homework question where it was the park benches, and this one here is equidistant from the sides. Okay, so the in-center will always happen inside the triangle. The circumcenter could be in, on, or out. So we got kind of multiple options. Alrighty, here we go. Let's go along. Let's get a different color here to spice it up. Write an equation of a line parallel. Whenever I see parallel an equation, I'm thinking same slope. To a point to the y equals 3x plus 4 that contains this point here. So the slope of the given line is 3, meaning the parallel slope is going to also be 3. And our point, our x1, y1, it's got to go through that point. So this is a point slope question. Y minus y1 equals m times the quantity of x minus x1. Y minus y1 equals m times the quantity of x minus x1. And it's point slope, and we use it when we know the slope and a point. So our y minus 10 equals 3 times x minus 3. Depending on how the question's asked, this way, there's an acceptable answer. If you want to carry it out into slope-intercept form, we're going to start by distributing the 3x minus 9, we're going to add the 10, and we're going to get 3x plus 1. So either one of those forms would be an answer depending on how the question's worded. Okay, similar question for 13. Write an equation for the line perpendicular. Okay, so again, perpendicular, I'm thinking negative reciprocal slope. So the first thing I'm going to do in this case is I'm going to find the slope of my given line. So I'm going to add 5x to the other side. I'm going to divide by 2. So y equals 5 halves x plus 3. So the given slope is 5 halves. So the perpendicular slope would be negative 2/5. And then we've got the point, negative 2, 4. That's going to become our x1, y1. Okay, because we know that it has to go through that point. So here we are again. Y minus y1 equals m times the quantity of x minus x1. Y minus y1 equals m times the quantity of x minus x1. So when you get those negatives, that's where it can be a little bit tricky for people sometimes. So y minus 4 equals negative 2/5 x plus 2. And I'll just leave it at that. In that case, it doesn't say put it into slope-intercept form. So, we'll just leave it here in this case. All right, moving along, last page here. So 14, find x, y, and z. All right, so we know we've got, let's see what we've got, 90. We just ask yourself, what do I know? Well, I know this is we got a linear pair over here. Okay, so I know that this is going to be 50, 180 minus 30. What do they all add up into a triangle? X plus 90 plus 50 equals 180. So this would be x plus 140 equals 180. So x would be 40 degrees. All right, 40 degrees. That means that's a vertical angle. That would be 40 degrees. All right. Well, what do we got going on over here? We got two angles in a triangle. So 180 minus 40 minus 90 would equal 50. So this angle over here would be 50 degrees. So that means y is a vertical angle with that. So y would equal 50 degrees. Okay. So then z plus 40 plus 50 would equal, would equal 180. That's a triangle. And so z plus 90 equals 180. So z equals 90. So x, we found y, we found z. All right, number 15, triangle TLM is congruent to SQR. What side is congruent to MT? So all I'm going to do, you could draw these out, but here's how I'm going to do it. Look at the order of the letters, because it matters in the congruence statement, and look what matches up to them. And so M matches up with R, and S matches up with T, so RS. Okay, real simple. Find the value of x. All right, now here's the thought process. So tick marks are going to tell us, hang on. Excuse me, I had to sneeze there. Tick marks, okay, say lead to, we have midpoints. All right, so this is a midpoint, this is a midpoint. Therefore, we have the mid segment. Oh my goodness, I had to sneeze again. Okay, mid segment. Two things you want to think about when you see the mid segment. Number one, you want to think parallel. Number two, you want to think half the side, or the side is twice the segment. So in this case, we could say 6x plus 40 equals 2 times 4x. All right, so the side is twice the mid segment. So 6x plus 40 equals 8x. If we subtract 6x, we get 2x. Divide by 2, x equals 20. Okay, so again, keep in mind, even though we didn't do it on this one, the mid segment is also parallel there. That's something we'll probably see later. All right, find the measure of angle ABC. All right, we've got two congruent sides. That means we've got two congruent angles. So if we just do 180 minus 80, we get 100. And then if we take that 100 and divide it by 2, we get 50. And so this angle would be 50, and that angle would be 50. All right. So that connection between the angle and the opposite side angle in the opposite side. That's shown up in a bunch of different questions. One of the common errors people make is they wrongly label the sides that are given. Okay, so just be careful in that case. All right, number 18, GE is the same as EA, and angle A is congruent to angle G. Okay, and then obviously we have vertical angles going on here. The triangles are congruent. So this angle over here would be 40 degrees because we're told that. So find the value of x. Well, 6x plus 40 equals 180. Triangle sum theorem, angle sum theorem. So 7x plus 40 equals 180. 7x equals 140. Divide by 7, x equals 20. All right, rolling along. Here we go. For exercises 6 and 7, state the postular theorem you could use to prove the pair of triangles congruent. So what we really need to do in this is we've got our givens, but we want to identify our freebies. Okay, so number 5, that is the common side. So this would be side, 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 congruent to side, side, side. And number 6, we've got congruent vertical angles. So that would be side angle side congruent to side angle side. All right. What postulate or theorem can you use to prove the pair of triangles are congruent? Name the congruents. Okay, again, we've got a pair of angles. If this is a right angle, that means that will also be a right angle. And here's our side. So this is angle, angle, side. All right, and the difference between angle, angle, side, and angle, side, angle is the position of the side. So you want to notice that the side, AB, is not, the endpoints of it are not the vertexes of the two angles that we have. Okay, over here, if we look at this, we've got angle, side, side. That's the donkey theorem. It doesn't work, with the exception of it being a right triangle, which we can use hypotenuse leg. Okay, so remember when you're doing hypotenuse leg, you have to say that the two triangles are right triangles. Okay, a couple more. Let's do 23 first, and then we'll go back and do 22. Find xy. All right, so what we want to recognize is that here's the relationship. Any point on the perpendicular bisector of a segment is equidistant from the endpoints. Okay, so that means that yx equals xz. So 8x minus 15 equals 3x. If we subtract 8x, we'd get negative 5x, divide by negative 5, and x would be 3. Okay, so reorder the reasons of the following proof to match the correct statements. So we've got the statements in order. All right, so let's just go ahead and do this. AB congruent to DC, why do we know that? That's a given, so we'll call that C. Angle ABC congruent to angle DBC, that's also a given, so we'll call that E, that's our other given. BC congruent to CB, that's the reflexive property. The triangles are congruent by side angle side, and then CPCTC, that's the last one. So just notice that corresponding parts of congruent triangles always has to come after you've said that the triangles are congruent. Okay, so hopefully that's helpful for you. I'm going to go ahead and do midterm review 3 as well. We'll have that as a video. And pay attention, go back, look at the points, make your own review sheet on this. So write down the things and review them for where you had some difficulty with stuff. And good luck. See you midterm week.